Word up. Nationwide hated. Nickel plate.
SQL or death? Yo, son, what are you going to choose? Yo, check it. This seminar is filmed at Carnegie Mellon University. Thanks a lot, Google.
Right, sorry. This is Jeff. He's been at Google for 20 years. He's touched every single database you know about at Google. He's phenomenal. He's super smart. He went to Waterloo. It's the best school in Canada for computer science. Talk about Pipe SQL. Jeff, floor is yours. Go for it. Thank you.
Yeah, thanks for the do-over on the intro. I'm happy to be here. I'm happy to share some of what we've been doing at Google to try to make SQL better for everyone. So I'm going to start with this idea that SQL has some problems. And I don't think that this is a new idea or particularly controversial. I like this Stonebreaker quote from a couple of years ago. He's talking about SQL and talking about it as a very old language, with a lot of annoying things that nobody's ever gone back and cleaned up, and kind of assumed that we can't. Here's another one from this talk Don Chamberlain, who's one of the original inventors of SQL, did a couple of years ago. It's like a very interesting talk on the whole history and evolution of SQL. Cherry-picked a few things here that I found interesting. He sort of contrasts SQL's English style syntax with what you might expect more as a programmer. He describes it as a functional language where you've got operators as functions that are orthogonal, that don't have side effects. And interestingly, SQL's not like that. One of the things he says, had they known all those decades ago how things might have evolved and that we'd be using them for this long, maybe he would have made some different choices. So the problem from my perspective is just SQL is way too hard to use. This affects everyone. For beginners, SQL can be hard to learn. And even for expert users who know it really well, it's still much more awkward and difficult to use, both when you're writing it and when you're reading it. I think fundamentally this stems from the syntax, where you write a query in SQL, you've got this list of clauses, select, from, where, etc. You can only write them in that order, and it's very rigid and very arbitrary. And doing anything else or anything non-trivial requires you to use subqueries or some other workaround. This structure creates this strange inside-out data flow where the query starts in the middle with the from clause or with nested subqueries and flows out from there with logic both above and below the starting point. There's also a lot of verbosity and repetition where you end up listing the same columns over and over again and select, group by, etc. Just the general complexity in the language, like the interaction of select and group by, which are written far apart in the query. So after 50 years, I think it's time that we fix this in SQL. And I don't think the fix needs to be replacing SQL. We can actually fix it. So there are a lot of things that are really good in SQL that we don't want to lose. The declarative semantics, the very fundamental level, works really well. The relational operators are nice. It's sort of the right set of operators and the right set of operations, and the table level composability things with views and subqueries, that works really well. Maybe even more importantly is the ecosystem around SQL. There's so many databases and query engines and other tools that all speak SQL. It's a very familiar language with a huge user base who knows it well. There's a ton of existing SQL code, and we don't want to give up any of that. Doing migrations is always really painful, both to learn and then to rewrite in new tools. So meanwhile, we've seen this pattern in many other languages and in APIs that are designed more recently, that they use this piped data flow syntax and structure. It works very much like Unix pipes, where you have a collection of operators, you chain them together with some kind of pipe connector, output from one flows to the input of the next. We see this in many query languages that were designed more recently. We see it in APIs like data frames or Flume. And users working in these systems generally find these fairly easy to understand and easy to use. So our solution is that we can do the same thing in SQL. We take all of the operators that you can do in SQL, we make a pipe operator equivalent of them, like using the same syntax as much as possible. Just allow chaining them together in any order, arbitrarily, any number of times. So you get query logic that flows from the top of the query to the bottom. It's very simple to understand what's going on. It's important to note here, it's still declarative, so we still expect optimizers to go in and reorder it to an optimal execution path. There's this detail, like we use this 2-character pipe symbol. It's slightly unfortunate. It's a bit of a compromise because the single pipe character, which we would have liked to use, but it's used for bitwise OR in our dialect and many others. It's not so bad once you get used to it, and we've seen the exact same symbol actually showing up in many other languages for similar purposes.
Maybe you'll get into this going back to the last slide. Like you have the 2 where clauses. Can you still put an and clause to combine them?
Yeah. You can do that. This is just for illustration that you can do where multiple times.
Okay, awesome. Thanks.
So here's an example from one of the queries from the TPCH benchmark. In this case, it's one that's doing aggregation in 2 steps. If you look at that query on the left, it kind of shows this weird inside-out data flow pattern you get in standard SQL, where you start in the very middle of that with the inner from clause. You've got logic above it, logic below it, and to trace through what's going on, you have to start in the middle, walk up, walk down, match up a lot of things. If you look at the pipe syntax on the right, it basically just expresses exactly what you want to do in the order you want to do it. Like start scanning a table, do a join, aggregate it again, sort, and you're done. So it ends up being very straightforward and easy to understand. So here's a list of most of the operators we've got. You can start a query with any normal from clause, including doing joins in the from clause if you want to. Many of the standard SQL clauses just get a pipe version of that clause with exactly the same syntax. It includes doing the select list as an operator. You also have some shorthands for adding, updating, changing columns in the select list without having to list out every other column you're keeping. We've made aggregation a separate operator, separating it from projection and making it a distinct thing in the flow, which we've found to be convenient for several reasons, including readability. There's a bunch of other operators. So you might have seen this picture. This comes from the paper from Cider last year and from the speakers from a couple of weeks ago. It's just a very clear illustration of the strangeness of standard SQL, where the order you write the operators in the syntax is very disconnected from the semantic order of what's happening when you run that query. And if we compare that, we write this in pipe syntax, basically we go in and uncross all those lines. It's very clean and simple because the syntax exactly matches the semantics of what you're doing. There's this sort of match between the relational algebra, the set of operators you're applying, and the syntax. You can go back and forth and translate in either direction. Yes, it's still important to note, like both of these syntaxes are declarative, so it's not specifying execution order, it's just semantics, and you'd expect to get the same performance and the same results writing queries either way. So interoperability is an important point. And one of the nice things about doing this inside SQL, we allow adding pipe syntax anywhere that a normal query would work. You can mix and match inside the same query across views, common table expressions in a with clause, and any query, including a query in standard syntax, you can add pipe operators on the end to do additional computation. And you can do this using all the same tools. So that example on the right is just showing mixing some operators in both syntaxes. So just briefly about our implementation. We've implemented in Google SQL, which is our shared component for SQL parsing, SQL analysis. It's used in all of our SQL related tools inside Google and in our cloud products, BigQuery, Spanner, F1, and others. And doing it in that query front end analyzer place, like we are able to generate the same intermediate representation for a query written in pipe syntax as we would in standard syntax. So for a query engine, they receive the same thing, feed it through their optimizer and execution, and are able to basically get support for pipe syntax for free just by enabling a flag without having to implement any new execution support. So that's great, and that's enabled us to support this in several tools. So we had this paper last year in VLDB. It has a lot more details on the language and some of the choices we made and some of the analysis. I'll talk a bit more here about like what we've been seeing from actual usage. So here's a graph showing usage in F1, users doing pipe queries. Like F1 is one of the main query engines users inside Google are using to query data. And important thing is to see the shape of the graph. It's just growing fairly quickly and accelerating. What we're seeing is that users see the syntax. Once they see it, they're able to learn it pretty quickly and want to use it. And it tends to be pretty sticky and to spread virally, like showing that the users are quite happy with it.
Do you have numbers that could maybe say like, would you know whether something like the pipe syntax is being generated by like a tool? Or I guess in the very beginning, there are no tools, so everything's handwritten.
Yeah, so this would mostly be queries that people have written. There are various tools that generate queries. I'm not aware of any that are yet generating a lot of queries in pipe syntax. I think that is one of the advantages, that as generating queries in code, generating them in this form is a lot easier, or should be easier. So yeah, I think this represents actual usage by people for the most part. So we get the question of who's this for, or who uses it. My answer is really, I think it's for everyone who's writing SQL, or at least everybody doing non-trivial queries in SQL. For the experts, or people who know SQL well already, it's really easy to learn this. It just takes a few minutes to show a few of the details there of how it works and a few examples. And it's a big benefit that it's the same operators you can do with mostly the same syntax, and it's just a better and more flexible structure for applying them. And these users find themselves immediately more productive writing and editing SQL. For the more beginner users, and also the set of users who have been exposed to SQL and don't like it, this fixes many of the more difficult and more annoying parts that cause a lot of users to not want to use SQL. So here's a few samples of the kind of feedback we're seeing from users. So I'm going to go through all of it, but there's generally
experience.
Yeah, it's overwhelmingly positive, and like I've seen these comments like this like multiple times, that this is maybe the most useful change they've ever seen in SQL, and the level of excitement is kind of amazing. We might look at that and think that it seems a bit overblown. Like, is it really that big a difference? I think there's I can show you examples side by side and like, yeah, this looks like a nicer way to write that query. It doesn't really capture the full benefit here. It's more than just a nicer syntax to look at. And like being able to work in this syntax actually changes the way you think and the way you can use SQL. It's very like freeing that whatever you want to do in a query, you pretty much can just do it and not feel like you're fighting against the language. So like beyond hearing that it's faster, it's definitely easier. Even like see users saying that it's been more fun working in SQL this way. When you go back to regular SQL after using this, you can really feel the awkwardness in standard SQL where there's so many things that feel like workarounds are more difficult than necessary. If you think about like how exactly it helps to have queries written in this structure, when you're building, editing queries, it's very nice that you can build them incrementally, and you generally like start with a from clause and just add more operators on the end. As you're building queries, at any point, the query is executable and you can run it and see what you've got so far, just add another operator on the end. And generally, you're adding operators that they're independent of most of what's going on in the query. You don't have to do these kind of global edits about keeping selects and group bys and subqueries all in sync with each other. Things like autocomplete and suggestion generally work better because the context comes from above where you're writing, which you don't really have that property in standard SQL. I think it's a good area for future exploration, but a lot the AI copilots for SQL, I think you could really take advantage of this and do something really smart and like really helpful. When you're reading and debugging queries or trying to understand performance, there's also a lot of benefits. Like these queries have this really nice prefix property where the query up to a pipe operator is also a valid query. So you can grab that prefix of a query and run it and see the intermediate results, or see the results before and after applying some operator like aggregation. At any point in one of those immediate queries, you can stick in another operator like an aggregation to see the count or the breakdown of values in a query, which tends to be quite helpful when trying to debug. I haven't done it yet, but I think there's an opportunity here to build an amazing IDE for working with SQL, where you could think of doing things like a debugger that single steps through a query. Like you can't even really think about doing that in standard SQL because just the syntax doesn't make sense to step through. I've also seen a lot of advantages of doing this like in a query engine that in the SQL language and in a query engine that people are already using. Because it's not like some new product, some new language people have to learn or make a big decision to start using. It's kind of a feature that's just there, and it's really easy to try it with no commitment and no setup. And also lets like one user just go try it first, maybe just try it for their ad hoc queries. And then like as they see value in it, they can spread it across the rest of their team. It sort of enables this viral spread where you can get somebody to try it and like it, and it goes from there. Versus like other approaches that might require bigger decision or some kind of migration where there's like you give up a lot if your existing queries don't work in a new syntax, or it's kind of all or nothing. Versus here, it's much more incremental. You can continue doing what you were doing before and use the new syntax only where it helps, and keep full interoperability with everything you had before. There's also this, you avoid some of the downsides that would come with extra systems and proxies or translation layers. So I had some challenges with debugging where you can't tell what's really running when your query's in a translated other language. You don't have to worry about any issues of cost or latency when going through an extra proxy layer. So now I'm going to focus a bit on extensibility, which I think is a very interesting area. I break this talk here about sort of 3 categories of extensibility when we're doing it, when the query engines are doing it, when users are doing it, or doing it in language design. So let's start with talking about table valued functions. And if you think about a table valued function, it's basically a generic relational operator, which takes one or more tables as input and produces.
Hey, Jeff, do you mind if I ask you a question real quick before we get into this? I was just curious if you've seen more use in sort of like OLAP style read-only queries, like, in BigQuery, for example, or if you're also seeing like, same viral growth in like, OLTP style, sort of like read-write ops and like Spanner.
Yeah, I think
like
this is definitely much more interesting in the read-only cases. Like when it comes to doing updates, there's not nearly as much value in the syntax. It's more about the read side of it. We don't really have an update or delete syntax to do this. We could do an insert where you can produce rows this way and like pipe them into an insert operator, but not really using it for transaction processing. And it's also like uses a kind of like ORM style read, modify, write transactions. There's not as much value there. It's more when you're exploring or analyzing.
Thanks.
Yeah. So I was saying like TVFs are basically generic relational operators, and you can add TVFs in a query engine. You can call them in standard syntax. The problem is that the syntax is really bad, really painful to use, because so it forces you into this nested subquery pattern of feeding the input into the TVF as an argument. It's especially bad if you're trying to chain multiple TVFs together. We've made a pipe operator form of calling a TVF, where it's just a top level pipe operator. You just do this transformation, which is like this argument in an object oriented call. So the input table gets passed as the first argument to the TVF, and then that allows calling them in a natural way, very much like a built-in pipe operator. So here's an example. BigQuery has a bunch of functions for machine learning operations. Several of them are implemented as TVFs. The example on the left actually comes from their documentation, showing an example of calling two ML model lookups, like calling an embedding model and then a classifier model sequentially. Really shows this inside out pattern, or like bottom to top thing that you get, particularly with TVFs in standard SQL. If you look at the pipe syntax on the right, it's obviously like much more straightforward, where you'd actually just call these operators, call those TVFs basically with close to first class syntax, except we didn't have to add any language or support in the grammar. We just allowed the engine to plug in more things just as functions. So I'll talk about extensibility by users with SQL. So here's an example. There's been discussion going on about adding streaming operators in SQL. There's a paper from a couple of years ago, and there has been discussion on this. It's kind of stalled a bit in terms of figuring out. I haven't reached agreement on how to do streaming, how to do these operations in SQL. So these three fundamental operators here are sliding windows, hopping windows, and sessionization. This paper was talking about how to do them as TVFs, which is a really nice approach semantically, because it makes them work like a relational operator you can plug in. But the call syntax using them as TVFs is quite awkward. The pipe call syntax would be nice for that. Other ways of doing it have been pretty messy. But this hasn't been added in SQL yet. So well, if you want to do it in SQL. Here's an example, computing sliding windows in SQL. So you see a query computing active users over 7-day sliding windows. So it takes records with dates and spreads them across 7 consecutive days. This block of logic in the middle here is the part that smears, like duplicates rows across 7 days with 7 consecutive dates, and then you can aggregate and get that sort of sliding window behavior. I won't walk through the query, but I think if you read it, it's fairly easy in this form and pipe syntax to kind of figure out what it does. The point here, though, is like if I end up doing this a bunch of times in a bunch of queries, there's this block in the middle or something similar might be repeated. You could copy paste that in every query, but it's actually much better to make it a reusable function. So I'll just grab that block of sequence of operators out of a query, and I'll make a table valued function out of it like this. It's taking basically the same set of operators, just encapsulating it into a function. And then when I go to call it, it's like a one-line call to do the logic that was inlined in the query previously. Effectively, it's a user-built extension to do sliding windows that then becomes very easy to plug into many queries in a way that looks basically like a first-class operator. So like this kind of encapsulation makes it possible to build libraries of extensions and write them in SQL, but make reusable operators. Now, technically you could do this in standard syntax with TVS too, but the syntax is so bad to call them that users don't really do it. Also, like, you don't really, in standard syntax, you wouldn't really even have this property of like, okay, here's a thing in the middle of the query that I could just snip out and run as a self-contained thing.
But isn't in this example, you have an implicit schema inside the extend dates function?
Yeah, so the function I wrote it this way, like assuming that there's a column called date, which is why I renamed a column to be called date when I called it. So a few like sort of unrelated features, but like some sort of reflection features where you could pass in a column name and resolve it would be really nice, and a little bit more powerful templating functionality would make this like even more powerful.
Can I ask about join on nest?
That's our join to an array. So like this is generating an array of 0 through 6, and then the unnest join is basically a cross product with that array that makes 7 rows.
So my question is, can you do that in a nested way? Like if you're in the from world with joins and SQL land, can you also, where you have like, maybe you have an array of objects or records with arrays inside of that, and you want to join across the hierarchy. Can you do that in the pipeline world, or do you have to go back to SQL world?
I think I might have missed it. Like you could write this join in the from clause too. So like you could do this query in standard syntax. It'd be a little bit different, but it's not doing anything new that's not possible.
Actually, I'm asking about the other way. I could let this go, but if you could scope inside of the join on nest to deal with nested hierarchies inside of the pipe context rather than the SQL from world.
Oh, like rather than flattening it out?
Yeah, just if you had like that complex example, array, object array kind of thing.
Yeah, you could definitely build the array. And there's lots of other things you could do. Like I'm not even saying that this is the optimal way to compute that operation. You could figure out a way to do it with window functions. It's a way that is actually, it was one I used when making the dashboards for the graph I showed earlier. So it's an easy enough way to understand. And the example was more like once I do something, I can snip it out as a TBF.
Okay, cool, thanks.
So now we get into the language design aspect of extensibility. If we talk about extending the SQL language, it's actually really difficult to add new operators to standard SQL, which is maybe why it doesn't happen very quickly. There's a lot of syntax challenges. Firstly, like where do you even put something into that select where from structure? Like it's often difficult to even figure out where you would put something to make sense. And once you figure out what you're going to do to fit something into a query, you have to figure out how to get it to work in the parser. And parsing standard SQL is very dependent on reserved keywords, which makes everything really difficult because adding new reserved keywords is always a breaking change on some query. So there's often a lot of compromises of trying to figure out some way to reuse something that you already have as a reserved keyword to avoid having to add new ones. There's also challenges in the semantics about how a new operator would interact with everything else that might be happening in the flow of a query, like whether there's aggregation or window functions, correlated subqueries, everything adds complexity, and it sort of creates this quadratic complexity of all of the interactions of other features of the language. And then, like, because of the syntax compromises, you have to end up something with poor usability, and often the new extensions require using even more subqueries to get something to work. Now, if we contrast adding something in pipe syntax, the operators are independent and orthogonal to each other. Parsing is generally really easy. It's one of the advantages of having the pipe symbol is that it makes a natural separator between operations so that they can all parse independently, and generally they don't need reserved keywords, and at least they don't interact with each other or cause conflicts. The semantics are also simple and local to each individual operator, and there's no global interactions or state across operators other than an input table and an output table. So it's much more like linear complexity when you're adding features. You just add the feature. You don't have to think about interactions. And for users, features added this way are great because you can just use the new operator anywhere, and it's fully flexible. So here's an example of a feature that has been added to standard SQL a long time ago. That the idea of recursive queries, like when you've got a tree structured data and want to do a tree traversal or graph traversal, it's really nice to be able to do recursive queries. The way they work in standard SQL is fairly bizarre. It's quite difficult to explain or understand how that query works. Like it uses this with recursive syntax. It's not really recursion in the normal sense. It's written as a union, but it's not really a union. A lot of complicated requirements on exact query shape that's supported, and execution rules where it's like grabbing one half of the union and running it, and grabbing the other half of the union and running it multiple times. It also requires to actually use it, you have to structure your query around this with recursive clause, which means once you want to put something recursive into a query, you have to often rewrite it. So here's our take on how to do recursive queries in a pipe operator. This is new. We haven't put it out to users yet, but we've got an implementation. So it starts just with a base query producing your input data, and then recursive union as an operator takes the input query and it runs the subquery repeatedly, adding more rows into the union until it doesn't get any more rows. It just returns the output of that union, and then the rest of the query continues. So you get both nicer syntax that clearly separates the base query from the recursive query. It's really easy to explain the behavior with simple pseudocode, and you get something that's composable. You can use it anywhere in the query, like in a sequence of n joins. If you want your third join to be a recursive traversal down a tree, you can just mix that into the middle of a query without having to restructure the whole query around with recursive clause. So I think it's an example of, with more flexibility in what we can do in the language, we can provide much nicer syntax for users. So why does language extensibility like this matter? As lots of people have probably seen this paper. It describes this recurring pattern of new things being created, often new languages, new data processing systems to solve problems in a new domain. And the argument is like, eventually we always find that we want to add those things back into SQL and back into their relational model. And we find in the end, we didn't need other systems, but it takes a long time. We end up creating those other things first. I think there's the way that like this pattern shows up when there's these new ideas, they're always getting developed in new systems and in new languages. If they're proven useful over time, then much later they get folded back into SQL. It's a very indirect path. And I think a big part of the reason this happens is that standard SQL is such a bad platform for innovation, where it's just very hard to experiment or add things into SQL, partly for these quadratic complexity issues I described earlier. So pipe syntax, I think, can change this because it becomes easy to add a new operator, and you can do it independently of everything else without breaking anything about existing queries. I think this is a potential way to unlock a lot of innovation. Like we can look at what are the good ideas that have come up in other places, in other systems, and we can add those operators into SQL, and we can do it fairly easily. And then the more forward-looking piece of like innovations for the future, what's the next big thing we should be able to do? Like, I don't think we need to invent a language for it and convince people to use a new language. We can just add operators and features in SQL. So I've got a case study here, or example of, I think, this happening and showing it working well. The problem area I'm talking about here, I'm calling it operational analytics, sort of the production monitoring, production alerting, where like production services are generating a lot of metrics, system collecting those metrics, time series. There's a lot of streaming systems that are capturing those metrics from production services. SREs and engineering managed services do alerting and et cetera. And generally, SQL isn't used in this space. I just assess the current state of the art in this space. There are a bunch of languages and tools out there, but compared to SQL, they're fairly primitive when it comes to query and understanding data. This is a problem we've got at Google too. Like obviously, we've got a lot of cloud services, production services, a lot of monitoring and reliability issues, and we've got a lot of tools that have been built up over the whole history of Google. And generally, like our SREs or engineers aren't very happy with the state of those tools. And I've been studying our options in this space for what we should do. The first option is like try again, invent another language for this. I strongly argue against that for lots of reasons. Inventing new languages isn't a great idea. It's not really a lot of reason to think that our third try at this will be better than previous attempts. So the next branch is there anything out there in industry or open source that we like and would want to use? We haven't found anything that seems compelling. So what about SQL? It's actually quite interesting because this has been a recurring discussion I've had with teams in this space like every couple of years over the last 10 years. It's always seemed like, yeah, we could do this with SQL, but like, would it really work? And would anybody really want to use it? With pipe syntax now, I see something has flipped, and it's actually like, now it makes sense. Now it seems like something people would actually want to use, and it seems appealing. So what we need to do is just add a few more time series operators for the kinds of things people do with this style of data, aligning, interpolating time series. And then we can make this whole space, like fold it together into the same ecosystem as SQL analysis, and we get a lot of benefits from that. So that's an active area, fairly early, but active area of work that we're trying to do next. So I think there's a whole lot of other areas where the same thing applies. I'm not going to go through the list here. There's just some areas that I'm aware of and thought some about, and like things I'd like to add to SQL. Sure, everybody else probably has their own list of things they'd like to be able to do in SQL or some other system. I think there's a lot of opportunity for the future. So I'll start wrapping this up here a little bit. This is something I saw recently in some headlines. It's talking about C++ and asking the same kind of question. That C++ is another language that's been around for almost 50 years, and we're asking if it's going to stay relevant in the future. In this case, like, is it going to be displaced by languages like Rust? I think C++ has a challenge and a more difficult starting point because the problems it needs to solve are about like safety and security issues, which are require much more fundamental changes to the language. If we ask the same question about SQL, what does SQL need for the future? I think our starting point is actually great. And like the first 50 years have been a great success, and there's not a lot in SQL we actually need to remove or change. It's not a lot that's broken. Most users aren't going anywhere else so far. Like maybe the most competitive thing would be people using Python, but it's not really quite the same thing. But I'd say SQL syntax is holding us back. It's a burden for users, and it's an obstruction to future growth and innovation. So my take on SQL for the next this century, next 50 years, first we need to fix the syntax, and pipe syntax is a really helpful way to do that. And we don't need to replace SQL. We don't need to give up all the good things or give up the ecosystem. If we just fix the syntax like this, for users, everything is still SQL. It's just a better version of SQL. And with the syntax change alone, like, it's already a great win for users, and they love using it. And it's a great change for the future evolution of the language. I'm quite optimistic here about the set of things that we could do. There's a lot of promise for the future of SQL if we take some of these steps. So that's sort of the end here. We've got, I think the best way to really get a feel for this, like, you can read our paper, it's got a lot more details. Like, the best way to get a feel for this is actually to try it. Just as of February, it's open to everybody to use in BigQuery. It's been implemented in Databricks and Spark. Their first release of this has just come out recently. So there's places you can try it on real data with real workloads. We've got some of our code available as open source. People can play with that. Really, I think the thing that's interesting for the community is, like, how do we go forward? Where do we support SQL pipe syntax in more systems, or eventually as a standard thing, I would hope. So that's what I got. Thanks for listening, and we'll do some questions.
All right, so I will clap on behalf of everyone. Jeff, that was fantastic. We have time for questions. So if you have any questions for Jeff, just unmute yourself and fire away.
Hey, Jeff, this is Jignesh. Good to see you after a long time. This is fantastic. The pipe syntax is awesome. One of the things that you often see with SQL in practice is some of these SQL queries are 500 thousands of lines long. And besides the syntactical ease of use which you get from what you described, the other complementary component is this cognitive overload, right? There might be 50 CTs that are defined before you get to the main query, and you're trying to figure out, like, which CT is this part referring to. Do you see problems like that, which I said are complementary to the pipe syntax, and are you thinking about how you might be able to solve that cognitive overload component?
Yeah, I think there's a bunch of things connected there. Like, obviously, at some point when you get to thousands of lines of logic, it gets overwhelming. People are going to, like, break something up with CTEs. That helps a little bit. There's one of the, like, some of the things that you can remove subqueries by using CTEs, but I still consider a CTE to be a subquery. You still have to, like, chase the names and follow the links, and you get, like, out of line logic. So, like, being able to write the logic linearly is helpful. It's still, at some point, it's, like, still useful to break things up into multiple statements. You can still use CTEs, give things names. I think that example I showed with TVFs of, like, pulling things out as encapsulated blocks of logic can be really helpful. I think that's something we can do more of. It's another parallel direction where we have more, like, modularization of SQL, so we have more, like, reusable building blocks, like more, like, code sharing, more code reuse. I call this, like, making SQL more like a real programming language, where you can actually have libraries and share them. So a variety of techniques. And it starts with fixing the syntax, but then we do more about, like, managing the complexity of some of the logic that people do.
That's great. One follow-up question. Do you think text to SQL gets easier if you had, of course, enough training data, but if that was in pipe SQL as opposed to the ugly SQL syntax that we have right now?
Yeah, I think, like, generating SQL from any representation in this form, I think, is easier. Like, if you're doing it in code, you generally have some data structure expression of what you want to do, like basically as a sequence of operators. And here you can basically translate your operators one-to-one into syntax, which is much easier than having to figure out like how to wrap things up into subqueries or CTEs, how to like what can combine into one query versus being a subquery. Like a lot of that goes away, and you can directly translate into operators. You don't have to have like cross-referencing nearly as much. And I think this applies both to humans generating queries, and also if it at some point is AI generating queries, I think the same benefits apply. I think a particular benefit beyond that with AI generating queries, like depending how much you trust what would come out of an AI model, I think human validation of the query is still really important. Like if you've looked at generated code that come out of other systems, it's usually a nightmare. The fact that you can generate something that is much more concise and much more readable in this form, like if you're generating something that you expect a human to validate, it's really nice to have it in a nice readable syntax.
Great, thank you.
Other questions from the audience?
Yeah, you mentioned standardization. How do you see that unfolding? Is this ANSI or an industry standard? What does that a SQL repo says? How's it going to work?
Yeah, I think like ultimately doing this in the SQL standard would be great, and that'd be the best way to get this into as many engines as possible. And like if we start, soon might be the time to start that discussion. Is if we're going to have this picked up in more engines, the more consistently we could do it would be great.
I mean, the standards committee is going to take at least 5 years, right?
Yeah, that's probably like we could have tried to start that way. I think like I don't think it would have worked to start that way, because just like writing this idea on paper without having tried it or demonstrated it, I think it's like a bit sounds like too much and sounds like we're crazy. And also like by actually doing it, we learned a lot, and like what we have now is informed a lot by like trying to build it, trying to use it, and like figuring out how it worked. And also like it's sort of like speculative that like this seems like it would work, but actually trying it and finding out how compelling it is once it exists, it's been useful. But figuring out the next step of like getting interest across the industry and with standard boards and figuring out that process, I think that is somewhere in the future.
I mean, if you can get it into like the SQL parse libraries in like Rust, Python, I don't know what the equivalent of C++ is, right? But basic every new database system written in Rust is using SQL parse. So if you can get it in that, that's like get you at least in the newer generation. Like Oracle's not going to put this shit in, right?
Yeah, I've seen this in some other like SQLite or Postgres or some others have said, yeah, this looks cool, but like, are we willing to be that aggressive on strange, innovative new features? Like if it's in the standard or like used more widely, then it gets like more permission for more places to do it. And we did it in our implementation, like directly in our tools, which is like I think the ideal way to get it as a user. Like the proxy approach of something that you can put in front that would like receive a query in this way and translate it into something that you could run on multiple engines, that still may make sense as a approach to get it working and usable in like much more broadly across other existing systems.
But do you even want to try to get into a standard? This is a layer above SQL, right? We don't have standards for assembly language. So does SQL become like an assembly language and this just sits above it? Or do you think that's not a good way to think about it?
Yeah, if you think of it as this rewrites into SQL, then you could take that view of it's another language in front. Like I think of it much more as a feature of SQL and much better as integrated into the language, like both because it should share syntax with like something you can do in standard syntax, you can do it in this syntax in exactly the same syntax. But I think that the interoperability, where like if you make a view in one syntax, you can use it in the other, or you can incrementally add things into queries this way. It's like really useful to support that incremental adoption and that interoperability, which is it works best if it's a feature of the language rather than another language in front.
All right, Nick from the Nick from the chat asks, can you talk more about what's coming next for Pipe SQL? Maybe by showing the slide again. What do you see are the priorities, domain-specific time series streaming, code fragment reuse, semantic model, pre-join, measures, fan-out aware? Or is the answer all of the above?
Yeah, it's kind of all of the above. Like some of these have more complexity than other things, and some of them are like somewhat parallel tracks that happen at different speeds. Like the time series and streaming, that's very connected to the sort of monitoring use case, which we definitely like. We're kind of early in like figuring out the operators we need, but it's one we're definitely working on. Graph queries more to me like hypothetical. Like we've been working on GQL and this SQL PGQ, so the embedded graph language inside SQL. Kind of some thoughts of like if you could just do the graph matching operator. So if it's a kind of shorthand for recursive queries inside SQL, like that would be neat. That's more exploratory. Semantic data modeling and OLAP query areas. That's another area of a lot of active work, and we're trying to figure out like what a SQL integrated solution where you can just do SQL queries over things that are semantic data models are like. It's a bit like more like a research project figuring this out, but I think that will be really neat if we get it working. Working with structured data. I think there's a talk a couple of weeks of Malloy. I think one of the things that's really nice that Malloy does is how it works with structured data and returns structured output. We've had in Google SQL working with structured data and protocol buffers forever, but all the SQL operators basically take a structured thing and flatten it out as a relational table. SQL++ is like works primarily on JSON. It's kind of the same approach as that, very, very similar to how protocol buffers or JSON work in Google SQL. Yeah, most of these SQL approaches basically turn things into flat tables as you query them. And I would like to be able to do more queries that build structure and preserve the structure as you query. So that might be one we do more work on soon. The SQL as a real programming language, modularity, code reviews, testability, like that's, I'd say that's another track, and we're doing a lot of work at Google in that area. And probably we should at some point publish some of what we've got. We've got several pieces there that are quite interesting, I think. Maybe in another 6 months or a year or something, we'll have enough of a complete picture that it's worth doing like a overall paper on what we've got in that area. But yeah, that was my sort of question to the audience. What are the next 10 things you'd like to fold into SQL?
There's a lot to do. All right, other questions from the audience?
Yeah, I have a follow-on to the standardization stuff. So let me lay out this vision. So no offense to people who like old SQL, but if your vision of this is like the new way for the next 50 years pans out and you really nail like the clean semantics of the pipe syntax, is there a way to prevent the backward compatibility of some of the crufty SQL stuff seeping into the pipeline? Or could you keep those worlds like very deliberately, maybe you have some backward compatibility, but there's like the canonical way you should write your pipe queries. One example is JSON arrays in many SQLs are zero-based, and SQL arrays are one-based. And so the same index operator works two ways. And so is there a way to like head toward the right outcome by writing your vision of this pipe syntax is the way to go?
Yeah, I think there's a bunch of things there. Like there's a few sort of more exotic operators that we've sort of experimented with a bit. And some of them probably come out as operators that only work in pipe syntax just because they don't fit anywhere into a standard SQL query without like a lot of difficulty and compromise. So we may get to the point of that there's certain things that sort of require pipe syntax to do some of the newer features. If we get to a point of like, we really want this to be the feature and want to sort of consider old syntax deprecated in some way. Like that's kind of just an option that you could put in warning or just like at parsing time or whenever, make it an error to do something in the old syntax. Actually, like there's a particular tool inside Google that was going to start using SQL, and they actually asked for the feature of could we put an option in so that only pipe syntax is allowed. And we hadn't thought of doing that so far, but like that's the kind of thing we could do. I guess another area of work I didn't mention is like we're working on a translation tool to take queries in existing syntax and convert them to pipe syntax. Not just as we've got something that can convert for consumption of query engines, but we want something to convert in a way that produces a idiomatic output that is like similar to what a human would have done as translation, and like produce something that's actually nice to look at, preserves comments and preserves all the aliases. And so if you wanted to migrate your code to the new syntax, I think we can make tools that will do that translation for you. Something we're working on. It's basically like a series of refactoring steps to like fairly algorithmic. I mean, you just have to implement it. It's basically like take a subquery and pull it out and put it in front of a pipe, and like basically just explode the standard query into pipe operators and then start simplifying it with a set of rules.
Cool, thanks.
Quick question. Jeff, does BigQuery use Zeta SQL or does it have its own parser implementation?
It's the same implementation. Like we have Google SQL as a component underneath all of our systems, and Zeta SQL is the same code as that.
Thank you.
All right, any last question? All right, so my last question would be like, what was the sort of the lineage, the progression of building this out? Meaning, did you just sit down at once, say, "Hey, let's try this," and you generated the pipe SQL sort of the first go, or was there sort of like an earlier prototype where you tried some things out that didn't quite work or make sense or didn't map to exactly maybe the semantics you wanted to achieve? I guess what was there anything? Was it a predecessor to pipe SQL?
Yes, it's interesting because it was kind of like the idea originally came, I think like 5 years ago. There's some docs sitting around that I wrote that long ago. It was kind of like a brainstorming exercise at that point. And we were sort of talking about some of these other languages like KQL and Splunk that like people use that have these sort of pipe behavior or pipe structure, and the users really like them in certain domains. And it was just kind of this thought exercise of like, what would it look like in SQL to do that? And it was like, at that point, it's like, yeah, this seems kind of cool. It's kind of radical. Like, do we want to do that much? Would it really, would we really want to launch it if we built this? We kind of just sat on it for several years. And it's more like a year or two ago, kind of coming back to it again. Part of it was like talking about this monitoring use case that I mentioned. And so trying to figure out the future of monitoring. And that was one of the motivations to like really do pipe syntax, because we could see like, well, there are people who do those kind of things in Kusto or Splunk and really like it and like would like to do the same. But there's a lot of things in that space. It's like once you get past the first few time series operators, basically you do aggregation queries to make your dashboards, and like being able to query that data, like do the time series stuff and then do regular SQL after, join to all the other data you've got would be really interesting. So that was one of the motivations, is like, okay, yeah, look, let's actually try this. And then it was like, we started implementing it, adding more operators. It just more further we got into it, the more compelling it seemed. And like, sort of, I think it's exceeded our expectations and realized like more benefits than we even sort of thought of ahead of time. Also like realized some of the things to like tweak or figure out of what operators we needed or we'd want to have in queries. So that evolved a bit more as we were trying it out, trying to use it and seeing others try to use it.